In this video tutorial, we will look at multi-object tracking with Ultralytics YOLO. In object tracking, we assign a unique ID to each of the detected object, and then we track that detected object throughout the entire video frames. We will also plot the movement of detected object across multiple video frames by drawing the trails, through which we can see what pattern the object is following. The applications of object tracking are limitless, from security and surveillance to real-time sports analysis. In this tutorial for object detection, I will be using Ultralytics YOLO11 model, and for object tracking, I will also use the Ultralytics package. Ultralytics package currently supports two object tracking algorithms. One is ByteTrack and other is ByteTrack. So currently, the Ultralytics package supports two object tracking algorithms, although there are other object tracking algorithms available as well, like deep sort, and others as well. But currently, the Ultralytics package supports two object tracking algorithms, which I told you. One is ByteTrack and other is ByteTrack. So we will be using Ultralytics package to integrate object tracking with our object detection model. So let's get started with this. Here you can see the demo is being played on your screen as well. In this demo, you can see that for each of the detected object, we have assigned a unique ID like 1, 3, 9, 10. And you can see that we are also checking the movement of the detected object by drawing the trails, which is telling us what path the object is being following. Okay, so this is a quick demo, and let's get started with this over here. So first of all, I will start writing down the code from scratch, and then I will show you how you can integrate object tracking with your object detection algorithm. So, but before I go ahead, you can check this documentation by Ultralytics, like how you can perform multi-object tracking with Ultralytics YOLO. So we will be following this documentation in this complete tutorial. So you can also check out this documentation, and you just need to search on Google by multi-object tracking with Ultralytics YOLO, and you will just find the first link, and you can just click that link and you will be able to open this documentation. So let's start writing down the code. So over here, you can see I have just created a project in PyCharm over here, and you can see I have multiple video files over here. And first of all, I will just create a requirements.txt file. We require the Ultralytics package. Okay. Along with Ultralytics, many other packages get installed as well, like opencv, Python, matplotlib, numpy, cbond. So we will install pip install -r requirements.txt. So now I'm just installing the Ultralytics package, because in my requirements.txt file, I have only mentioned the Ultralytics package. Spellings are wrong for the requirements. Let me see. Let's run this. So if you have mentioned any other package in this requirements.txt file, this will also be get downloaded with the Ultralytics package as well. So currently we only require Ultralytics package along with Ultralytics package like SkyPy, Torch, opencv, Python, numpy. Many other packages get installed as well. Like you can see matplotlib, opencv, Python over here. Okay. So numpy. So you can see over here, many other packages are being getting installed. Pandas. So let's try create a new .py file over here. So we'll write object tracking .py. So in the step number 1, we will import all the required libraries. So from Ultralytics import YOLO. we will load the YOLO11 model. So I will let model is equal to YOLO, and we want the YOLO11 Nano model. YOLO11 comes with 5 different models. YOLO11 Nano is the fastest, but it is the least accurate among other YOLO11 models. So first we will see tracking with default tracker bot sort. Okay, so if you just check out the documentation over here, you will find that the default tracker is bot sort. Okay, so if you don't define the tracker over here, like you write model or track and don't define the tracker over here, let me just zoom in a bit. Okay, and so if you write model or track, but you don't define the tracker over here, it will use the default tracker, which is bot sort. So Ultralytics YOLO supports the following tracking algorithm, bot sort and ByteTrack. So you can enable any of these tracking algorithms like either bot sort or ByteTrack by passing the bot sort.yml file or ByteTrack.yml file. So by passing the relevant YML configuration, you can activate any of the tracker. Okay. So if you want to check the informations like on the Ultralytics tracker base, like currently you can see it's post two trackers, bot sort and ByteTrack. Okay. So let's move towards the code. All right, results model dot. So if I want to do object detection, I don't need to write anything. I just need to go over here and write the source in which I need to pass the video path. But if you want to add tracking, you just need to write track over here. And then you just need to define the source file, like your input file over here. So I just need to go to the resources folder. Then I just need to go to the videos folder. And I can use videos 7. If I want to show this video, I can write show is equal to true. And if you want to save the output video, you can write save is equal to true. So shortly, our packages will be getting installed. Like currently, it's doing indexing. So this will not take very much time. So let's wait for this to finish. And then I will just implement this code. So now you can see currently we are using default tracker bot sort because I have not defined any tracker over here. Okay. So let's wait for the packages to get finished. So now you can see that finally the package installation is being done. And now let's run this script over here. Okay, so the indexing is almost completed. Let's wait for a few seconds. The indexing is being done, so this will not take very much time. Okay, let's run the object. So it takes around 5 to 6 minutes for the Ultralytics package get installed, because with Ultralytics many other packages also get installed. So this takes some time. Okay. So first of all, it will download the YOLO11 Nano model. It automatically downloads. You don't need to go to the GitHub repository and specifically download the YOLO11 Nano model. Okay. Okay, now you can see over here. Okay, so we are just getting issue no module name lab. Okay, so we can just write over here. We also need to install the lab package as well. Ultralytics should include in their installation, like we don't need to install it specifically. So now you can see I'm installing the lab package over here, and you can see YOLO11 Nano model is being downloaded. So this installation will take few seconds more as well. So let's wait for it to get finished. We can ignore this. Let me just check. Hopefully it should run now, and let's see how does it. It will perform an auto update over here. Okay, so over here you can see we have the results. Now you can see that ID is equal to 1, and here we are detecting the cars. So okay, but we are not able to assign the, we are not able to do the detections over here. Okay, so now you can see as the object comes here, we are able to do the detections. Now you can see that each of the detected object is being assigned a unique ID. Now it looks pretty good. Yeah. So now you can see that each of the detected object is being randomly assigned an ID. Okay. So if you use, currently I'm using YOLO11 Nano model, but if you use other models like YOLO11 Medium or YOLO11X, which have a high accuracy rate, so you will see that detection results will further improve. Currently, I'm running it on my CPU machine. I don't have a GPU, so therefore, I'm preferring YOLO11 Nano model because it is the fastest among YOLO11 model, but it is least accurate. Okay. So now you over here, you can see that we are able to do detection and we are able to assign a unique ID to each of the detected object over here. Okay. So now you can see this is a wrong object detection over here. I currently am using YOLO11 Nano, so therefore there are some false positives over here as well. But this is what we do in object tracking. Like you can see, we are assigning a unique ID to each of the detected object. Okay. And to stop this, I will just click the pause button and it will stop. Okay, so next thing what we can do is we will see how we can do tracking with ByteTrack. Okay. So we will just define results is equal to model.track over here. Source is equal to, let's use some other video. I just need to go inside the resources folder, then videos, let's use video 8.4. I want to see the output, and you can see over here, our output is being saved over here for the previous run. Okay. Show is equal to save is equal to pro. And we want to use ByteTrack.yml. And you like for the prediction in YOLOv8 model, we have different arguments. Similarly, we have arguments for the tracking as well. Like we can set the confidence threshold to 0.20. We can set the non-expression IOU to 0.5. So you can adjust these parameters. So we can make it. So let's run this now. Okay, I made a mistake. I just need to comment this out. Over here, we have the output. Now you can see over here, we are able to detect the person over here in this video. And you can see that with each person, we have assigned a unique ID like 7, 6, 3, 2, 1. Like you can see, we are not able to detect these persons. But if you use other YOLO11 models, currently I'm using YOLO11 Nano model. But if you use models, other YOLO11 models, which have a high accuracy rate, then it will be able to detect these persons over here as well. Okay. But in this tutorial, we are focusing on object tracking. Basically, in object tracking, we assign a unique ID to each of the detected object. Like you can see over here, we have assigned a unique ID to each detected object, and then we can track that detected object throughout the entire video frames. Okay. So we are done with this, and that was pretty fine. Okay. So now, first of all, I will just comment all this. Okay. So you can uncomment this and run this. Okay. So now I will just write a Python script using opencv Python and YOLO11 to run object tracking on video frames, or you can also run on the live webcam feed as well. Okay. So let's add a separator. So we will write a Python script using opencv Python and YOLO11 to run object tracking on video frames and okay. So let's get started with this as well. So first of all, we'll import all the required libraries. Import CV2 from Ultralytics, import YOLO. We'll load the YOLO11 model. So right model is equal to YOLO11 nano.pt. Next, we will create a video capture object. So write cv2.video capture. We just need to go into the resources folder. Then we just need to go to the videos and we can use video 7 or we can just use video 5. Let's use some other video. Then we will loop through daily frames. So I write while true red frame is cap.read. So if we have able to read the video, because red returns a boolean true, so if red returns a boolean true that is able to read the video, then we will run YOLO11 tracking on the video frames. So we'll write results is equal to model.track. We have the input frame and we will set our argument persistent is equal to true. So this argument tells the tracker that it should expect tracks from the previous frame or image in the current frame. So persistent is equal to true tells the tracker that it should expect tracks from the previous frame into the current frame. Okay. So next we will visualize the results on the frame. We have annotated frame is equal to results 0. Log. Next, we will display the annotated frame. We can write the name of the window as YOLO11 tracking. So now, in this window, we will show object tracking integrated with our object detection. All right, if cv2.wait key. So we will add 1 millisecond delay between the consecutive frames. And if the users press Q key, then the loop will break. So we can add the command break the loop if Q key is pressed. Simple. And if it's unable to read the video frame, then it will break as well. And then we will release all the frames and we will destroy all the windows as well. So let's run this up now. So now over here, you can see that we are able to integrate object tracking. Like you can see that for each of the detected object, we are able to assign a unique ID, like 1 with this person, 6 with this bicycle, and 8 with this bicycle. And the results look quite good. Like you can see with traffic lights, we are also able to assign a unique ID over here. Okay, so the results look quite promising to me. Okay. Yeah, the results look quite good. Like we are able to assign a unique ID with each of the detected object, like 17, 15, 8, 3, 1, 14. Okay. So if I press Q key, the loop will break. That is. So the next thing we can do is now we'll see what path the object is following. So we'll draw the trail. So we can create another Python script over here. Object tracking dash trails. So we will be plotting tracks over time. So we will plot the movement of detected object across multiple video frames. First of all, I will import all the required libraries. We will be saving the center point of each of the bounding box into our dictionary, and then using that center point, we will be drawing lines. Okay. So we will be saving the center point of the bounding box in each of the frame in our dictionary, and using that center point, then we will draw the lines. So now we'll load the YOLO11 model, then we will create a video capture check. We just need to go inside the resources, then we just need to go to the videos, and then we can use video5.mp4. So we will store the track history into a dictionary. Then we will loop through the video frames. Cap.read. So if we are able to read the video, then we'll run YOLO11 tracking frame. Right, results is equal to model.track. Here we have the source which is frame. Now we need to get the bounding box coordinates and the track ID. We write boxes is equal to, because this will contain the bounding box coordinates for all objects in the frame, and then we'll loop through this. So we can write result 0. We require business center coordinate. Then we will also require the track IDs. So we'll get the track IDs for all the objects in the frame. So similarly, in the previous .py file, we'll write the results on the frame as well. We can write annotated frame. So I can display the annotated frame as well. So then we can write if cpu2 dot wait key 1, there is a 1 millisecond delay between the consecutive frames. And if the user press the W key, I missed one thing over here. Then the loop will break. So now I will release all the frame and destroy all the windows as well. So let me just run this. So now currently you can see that we are able to do implement object tracking, but we are not able to draw the tracks which show the path the object is following. So I just press the W key, it will close. So we need to plot the tracks. For this, I will write the code over here. So now we will loop through the center coordinates and the track IDs. So I will just write box format track ID and zip. Here we have the boxes format track ID. So here we have created a default dictionary by the variable track history. Now it's time to use this. In this track ID, we have the object IDs for all the objects in the frame. So with that, each track ID will save the center point of the bounding box, and we will then connect the center point of the bounding box for all the frames, and then we will draw the lines which tell us the path the object is following. So we need to retain the points or center points for the 30 frames. Okay. So we write and track 30. So we will retain the center points for the 30 frames. So if you increase this value to 60 or 90, the, the tracking trail line will increase. Okay, I will just show you as well. Now we will draw the tracking lines. So using cv2.polling lines, we will draw the trails or the lines. Here we have the information of the center points. And the thickness will be 10. Okay, so that works pretty fine. Let's sum this up now. We can just use video. It. So let's see how does it works. So the color of these lines will be a white because we have just set the color to white. You can just change to color any other color as well. Okay, so now you can see in the white we have the trails over here. So which shows the path the object is following. Okay, so now you can see over here we have the trails over here. So let me just show you with other videos. So, and we can just change the color to blue. Let's run this now. Okay, so here we got the error. So yeah. So how we can deal with this? We can write if results 0 of dot id is not null. Okay. So now hopefully this will work out. So let's see. So now over here, you can see that we are drawing the trails with blue color over here. Okay. Okay, so now you can see that these trails are telling us the pattern the object is following. Okay, so now you can see over here, we are drawing the trails over here as well. So if I just press the W key, this will close. And if I just write 90 over here, let me show you what effect does it makes. if I just write 90 over here, the length of these trails will further increase. Okay, so now you can see that huge. Basically, this is telling the path the object is been following. Now you can see that the length has so much increased. Okay. So this is how it makes impact, but 30 is the ideal value. Okay, so now we have seen that how we can plot the movement of object, how we can integrate object tracking. Now we will implement multi-threaded tracking. So multi-threaded tracking provides us the capability to run object tracking on multiple video streams or multiple live webcam feeds as well. Okay, so we can create another .py file. So multi-threaded tracking provides capability to run object tracking on multiple video streams. Okay. So first we will import all the required libraries. Import threading, import CV2 from Ultralytics, import YOLO. So next we need to define model names, like what different models we need to use in the multiple video streams. And video sources, you can also define the webcam sources as well. We are going to use YOLO11 nano model, and we will also use YOLO11 nano segmentation model as well. So we have sources equal to, just need to go inside the resources. Then there will need to go to videos, and first we'll run video 7.mp4. Then we have sources, videos, video 8.mp4. Okay. So now we will run YOLO11 tracker in its own thread for concurrent processing. So we'll create a function. Okay. Run tracker thread. We just need to pass the model name and the file name in the input. So we'll run YOLO11 tracker in its own thread for concurrent process. So we'll pass the model name to the over here. Then we'll write results model.track because we need to implement tracking. Then in the source over here, we have the file name. We need to save the output video. Then we need, in the documentation, they have set stream is equal to true, but this doesn't show the output video. So we just need to write show is equal to true. Then we will loop through the results. Now we'll create and start tracker thread. So we'll now create and start tracker threads using a for loop. So now we'll loop through the video files and the model names. So the arguments will be model name and the video file. So now we will run YOLO tracker in its one thread for concurrent processing. I will show you in the output how this works. Let's start this up now. Now, before it completes, for example, if any video completes, it will wait for all the tracker threads to finish. Now we'll clean up and close all video frames. So now we'll clean up and close all windows. So we'll write cv2.destroy all windows. So this is how it works. Let's run this and see if it works. So we have YOLO11 nano model, but we don't have the segmentation model, so it's downloading. And so this is our first video. And here is our second video. You can see over here, we are able to implement multi-threading. So using multi-threading, it provides us the capability to run object tracking on multiple video streams. Like you can see over here on one side, I'm implementing object tracking with the segmentation model, and on the other side, on the left-hand side, I'm implementing object tracking with the object detection model. Okay, so now you can see that the results look pretty good. Like you can clearly see over here, the results look quite promising to me as well. Okay, so now using a multi-threading, we are able to implement object tracking. So the results look quite promising. So now we are able to implement object tracking on multiple video streams as well. So multi-threaded tracking provides us the capability to run object tracking on multiple video streams, which you can clearly see over here. And over here, you can see that we are doing concurrent processing. We are running video 7 and video 8 in parallel over here. You can also run on live webcam feeds. Like if you have multiple feeds coming, you can run it on multiple feeds as well. And you can see this is what we call concurrent processing. Like we are running video 7 and video 8 concurrently at the same time. Okay, so this is how it works. And using multiple threading tracking, we have run object tracking on multiple video streams. That's all from this tutorial. Thank you for watching.